I'm Doug Miller from KMC Controls, and I'm here today with Erich Kreuter from KMC Controls as well. And we are here to talk about KMC's product called Simply VAV. Everything that we are going to talk about today and review is available on a website called simplyvav.com. All the information, all the data sheets, all the I/O, everything you would need, as well as some embedded instructional videos on how to install the product, how to mount it, how to wire it, how to configure it, how to air balance it, are all there on the website. So I would encourage you to visit simplyvav.com for a review of what we're going to talk about today. There we go. Okay. This is a picture of the Simply VAV controller and its companion room net sensor or room temperature sensor. Again, it is a very easy path to digital VAV. In the old days, we did a lot of pneumatic VAV. This day and age, everything is all done with direct digital controls. And Simply VAV is a BACnet compatible product. It speaks BACnet native MSTP out of the box. It'll work in a standalone application should you need to employ it in that perspective, but it also can be integrated into a BACnet MSTP network. It's easy to install, it's easy to set up and commission, and there's models and options available to meet almost any cost point. Picture of the controller itself. In the upper left-hand corner, you see the V-bolt for mounting the controller on the shaft. Down here, there's one screw to mount in the anti-rotation bracket. Up in the upper left, or in the center here, is where your differential pressure, your airflow sensors connect. You have color-coded power wiring. Your various I/O options are available on the terminal strip here on the right. You have color-coded communications for your thermostat, or for your communications connections, your MSTP bus, and your thermostat connection. And an important thing to point out there is no matter which KMC temperature sensor you are using to connect to the Simply VAV product, it is all done with a standard Ethernet cable. It's not a crossover cable, it's not a patch cable, it's not a specialty cable that's going to drive your cost for the job up. It's a standard Ethernet cable. You can go purchase it at any electronic supply house, Best Buy, or electronic supplier of your choice. One of the things that you will discover, as I mentioned earlier, the QR code. This is on the front of the thermostat when it comes out of the box. Your field guys can use that with their smartphones to go to the Simply VAV website to pick up the things that I mentioned earlier. One of the key and most important points about Simply VAV is there is no software to buy or to learn. Let me say that again for emphasis. There is no software to buy or learn. Everything you need to apply this product is embedded in the factory, and it comes out of the box ready to be installed and commissioned and started up. It will let you configure the controller, adjust your user settings, perform your commissioning, and obviously let the air balancer, if it's a plan and spec job, go out and do their thing without having to tie you down. Available in a few different models. There's a single duct cooling only model, very popular. There's a fan-powered reheat model. There's a model that's available that has integrated damper feedback position if you need that. And there are a couple of dual duct flavors available. Dual duct is not real popular, but you do run into those occasionally. And when you do, this gives you a cost-effective way to approach it from a retrofit perspective. On the sensor side, the STE8001, this is your software configuration tool. This is the device that you will use to start up, commission, balance, and install the system. There are, however, a couple of other flavors of discrete, smaller thermistor-based occupancy or temperature sensors that you can use. They're available with or without set point, with or without override options. If the job dictates that you have to go this route because of cost, one thing to bear in mind is you will need at least one STE8001 controller simply to use as a configuration tool at the startup, and then when you're done, you can go ahead and take that off and plug the STE6000 or the smaller temperature sensor back in. We also have a full offering of accessories you'll see in the upper left-hand corner, if it's an old job and the boxes, the flow probes are gone or they're missing or they're not functioning correctly, we can sell you an entire kit to retrofit it on the flow probe side that you can order from us. You'll also notice there's different combinations of back plates that are available for the devices. We realize that in our world, our thermostats, if you noticed, our temperature sensors are designed to be mounted on a vertically oriented 2x4 box. However, in a lot of retrofit applications, you may find that it's a horizontally oriented 2x4 box. We make a backplate kit that allows you to change that orientation from horizontal to vertical. And the major point of this slide is to show you again, to reemphasize the point I already made, that no matter what Simply VAV controller you pick and what line of companion temperature sensor that you use, it doesn't matter how you cross-connect them, you can use one standard Ethernet cable to connect all the devices. Some noteworthy features. Our products are manufactured in the United States, up in northern Indiana. It's a family-owned, privately held company. Our sensors are hot swappable, so if you have an application where for some reason you need to change out the sensor on the fly, you don't have to power down the box or the entire system to do so. As I already mentioned, it can be used in a standalone or in a BACnet network configuration. On the airflow side, you do get true static pressure differential, and obviously it is dead-ended, so pickup tube lengths don't matter, so you don't have to worry if it's more than a few feet away. And you do get very accurate readings with the SSS probes. From the occupancy side, there's really 3 occupancy states if you're dealing with, per se, a conference room or someplace that doesn't have a regular occupancy scheduled to it. It can be determined by any number of things, by airflow or by an actual occupancy sensor on the front of the device. And it'll essentially give you 3 modes: occupied, standby, or unoccupied. On the reheat side, you can control up to 3 stages of electric reheat. On the modulating output side, we can give you either floating control, modulating control, or time proportional control of your hydronic reheat valve. So I think we got most of the applications covered on the reheat side. Advanced reheat logic that says we're going to maintain our discharge air temperature within 15 degrees of our return air temperature, and obviously the purpose of doing this is to make sure that we operate the system not only simply but efficiently as well, so we're not wasting energy in our retrofit application. BTL, BACnet Testing Laboratories. A lot has been said about BTL. BTL, if you're not familiar with them, they are an independent third-party organization. They're kind of like the underwriters' laboratories of the BACnet world. Anybody can make a product and say, hey, I'm BACnet compatible, right? Well, the ultimate way for a manufacturer to put his money where his mouth is to send the product to BTL for that independent third-party testing. They take your product, they test it for the BACnet test or the BACnet standard you have submitted it for, and if it passes that test, it gets to bear the BTL Testing Laboratory stamp. If you go to BTL's website, you can look up by manufacturer and open their page and see all of the various products that they have listed that they have put through the BTL testing. It costs a little bit of money to do that, but we believe in the end it's worth it from a credibility perspective. There are no proprietary objects in our network. We adhere to the BACnet standard fully, ASHRAE standard 135 from top to bottom. If you go on our website, on the Simply VAV website, you'll see our PIC statements there, which will tell you what you can read, what you can write to our controllers. Again, all standard objects, nothing proprietary, and it's all available on the website. You have some network bulbs here that help you to ensure functionality of your onboard communications. In the next slide, we'll talk about what those mean a little bit more. So to give you, for instance, those diagnostics will say things like, hey, I need an air handler out there. Maybe the fan failed or something like that. I have no airflow. Or, hey, I need more warmer air, or I need more cooler air, depending on what the zones are calling for at the time. Or, hey, I need more static pressure. I've got a lot of boxes open. I need more static to satisfy the load in the ductwork. But the key, and again, I'm going to mention it again because it's worth it, there is no software to buy. There's no software to learn. You don't need a laptop. You don't need to go sit in a training class for a day to learn how to use this product. Everything you need is embedded, hard-coded into the devices at the factory. It's truly wire it up and plug and play. Now we'll flip over and let Mr. Erich.
I'm Erich Kreuter, KMC Controls. I'm a hardware product manager. I'm going to talk to you a little bit about the FlexStat zoning equipment controller that is a companion product to our Simply VAV product line. So for zoning applications where you have multiple zones, pressure independent systems, we can install a FlexStat on the rooftop or the heat pump to stage up or stage down that DAT to deliver heating or cooling as necessary to the zones. One ZEC will go out and pull up to 16 zones of Simply VAV for the demand they need, either heating or cooling. The ZEC also does not need any software, just like Simply VAV. We don't want to have you do any programming on site. We want it simple out of the box. So the steps you would need to set up a zoning controller would be select your equipment type, rooftop or heat pump, one stage, two stage, three stage, etc. You're going to select what address range, what backnet instance range is going to be pulled for that zone demand. You can configure a schedule as 5 and 2, 5, 1 and 1, individual days, or with holiday exceptions. And then you're going to just confirm your DAT set points. Defaults are 55 and 130, but they could be adjusted to whatever the job spec needed. And you're done. When it's operating, the display will show you current discharge air temperature. It will also give you quick status of what the equipment's doing, if cooling's active, if you're occupied or unoccupied, or if the fan is running. The fan can run continuously while occupied, or it can cycle as a configurable property. And then it will tell you how many cool calls or heating calls are active or how many zones are connected. So quick troubleshooting, make sure all the devices you think are communicating are actually seen on the system and are reporting their demand. The other feature that's good for debug, so if you're looking at this through BACnet or a JACE, there's factory configured trending for DAT in a few different intervals, so you can see trends. You can make sure your equipment's staging up and staging down properly. We trend the number of zones and the heating cooling demands. And we also duct static pressure and both the set point and feedback. So with that, do we have any questions about the zoning equipment controller or Simply VAV?
How many zones did you say you can see at any one time?
16.
16?
Right. There is an option. We do have a open program. So if you want to do something outside the box, you want to do 18 zones, or you want to do a custom instance range, or fan control if you got a VFD, we do allow that to happen in this same product. But out of the box, it will do 16 zones of zone controller. And I think between the price of the zone equipment controller and the Simply VAV, we're really trying to sell pressure independent retrofits of VVT systems. And I think retrofitting a VVT is relatively expensive and you still get pretty poor performance because you're still pressure dependent. We're advocates for pressure independence because you can deliver to the zone true demand, true cooling and heating that they need. So.
Hey, since we got you doing the tape anyway, it might, and I'm thinking control trend stuff too, it's
Sure.
Like newer people. Could you take a minute and just explain the difference between pressure independent and pressure dependent?
So pressure dependent is where we are not monitoring flow. So for a VAV box, normally you would want to say 100 CFM to 400 CFM, min and max. So full cooling is 400 CFM. Minimum cooling that you'd get out of your box is 100. In pressure dependent, you're controlling damper position, so all the way closed or all the way open. And with that, there's no guarantee of how much air is actually going through that VAV box into the space. If you have very low static pressures and you're wide open, you might be getting 100 CFM. If you have very high pressures and you're full open, you might be getting 600 CFM. So it's really inconsistent comfort for your occupants. Pressure dependent systems also, because you have no guarantee of how much airflow is going through, you're not getting enough dehumidification generally through your equipment. So VAV provides, pressure independent VAV provides better comfort, better ventilation, and better performance overall in your system. Sure.
I was trying to remember that you're independent, you're better.
Yep. The greatest example I always use, I think, is of two conference rooms. One that has 2 guys, one that has 8 guys. They're both equally sized, so they're both designed for maximum load. If it's pressure dependent, the conference room with 8 guys is going to, eat up all the air that air handler can put out. The room with 2 guys is going to become satisfied very quickly, close its box. All that air now is going to be pushed into the conference room with 8 guys, and it's going to subcool that space very quickly, probably faster than the stat can catch up. So now they're going to be uncomfortable. That box is going to start to close. Maybe the 2 guys, need a little bit of air, and they're going to fight each other the whole time. In a pressure independent application, I can guarantee that the 2 guys get the cooling that they need, and the 8 guys get the cooling that they need, and it's properly sized for the demand that's actually there.
I think I missed something. One flex stat, 16 zones.
Yep.
But if we put 16 zones out here, how are we gonna, there's gotta be something else in the space that's sensing something, right? So if we just put one flex stat.
So the flex stat will be mounted on the equipment.
Okay.
And the Simply VAV each zone would have its own temperature sensor, either an ST8000 or an ST6000.
But you're still using one flex stat up to 16 zones, so where's that one flex stat?
The flex stat's no longer controlling room temperature, it's controlling DAT on the equipment.
Okay.
So if it sees that 9 zones need cooling and 7 zones need heating, we're going to default to majority winds, we're going to run our equipment in cooling mode, and we're going to control that equipment to maintain a 55-degree discharge of that equipment.
So you still have the Simply VAV on the wall.
Yep.
And then you have one flex stat for every 16 zones.
Yep. One flex stat for every piece of equipment, and it's looking at DAT versus onboard room temperature.
Now, do you, I assume that you can have multiple flex stats on a system and you can tell Simply VAV which address they?
Right, so if we go back here, the internal programming will allow 4 ZECs on one BACnet network before you have to deal with any conflicts. So you'd pick 1 million instance range, 2 million, 3 million, or 4 million. If you want to grow beyond that, or you have a custom instance range, say a building owner says use 10,000, 20,000, 30,000, you'd have to go into the program and change what those addresses are.
You do that via like a BACnet interface, or is it actually a programming software?
That would be with a software utility from KMC.
Like Backstage or something?
Yep. Yep, those programmings, it's just like a regular flex stat. They're exposed, but they're not editable. So you'd shut off the factory program, turn on the open program and do your custom programming there. And then you can use the staging program that we already have there to control the equipment.
So that's something we could do for a customer if they wanted something special. We could do it here, then send it out, and
Yep.
then they're still using the flex stat. They don't need software or anything.
There's no software on the job site then. They would just have to set their schedule. We did a special app note for the ZEC on setup, and it's basically, here's how you set your schedule, because to the end installer, they're mounting it, powering it, setting their schedule, and setting the addresses in the Simplies. That's all they need to do.
Yeah, you have to bear in mind, this product was designed for your average contractor that walks in off the street that doesn't do controls often, right? But occasionally he runs that after. That's the market you serve. Right. And this was designed to give him something that he could take it out, connect it up, power it on, enter in his start, stop, and his temperatures, and then be done.
Well, I think the other thing too, Sam, this gets back to the counter, would be that if somebody needs, a VAV controller or something like that, you could sell them this as a standalone, and
Yep.
then later on, if they wanted to network it, they could just run the network, and so it seems like you have the best of all worlds.
Right. And we have a couple applications, like in our factory, we put one of these in the sales wing. We also have a warehouse there that's teed off that same rooftop. So we didn't want the warehouse to be in the voting of where to run the equipment because nobody's out there. We just want to maintain, you know, basic. We just addressed it outside of this range, so it gets to ride along, but it doesn't affect the control. So there's some neat applications there you can kind of manage without having to get software out again.
So out of the box, you can have 4 rooftops, 16 zones.
Yep.
And the change of program, that's not within the unit itself, that's a separate software?
Right.
Where would we get that software? Is that online, downloaded from the site?
Yeah, you guys have access to that. I don't know how you have Backstage now, but
It's a licensed piece of software that we
right.
have.
The other,
Wouldn't be a piece you would worry about selling.
right.
No.
That would be something you guys would do
Something
here.
like how we program the actuators, we would actually have it on the computer to program.
Just say, I'm not sure, I think you'd only need that, the guys you sell to would probably never, ever need that at all.
Right.
The only time you need that is if you wanted to change the default.
Right, that's it, right. That's-
So then the building automation guys would do that.
And generally speaking, if they want to do the change the default, you need to be having Michael or
Right.
somebody else.
Okay, so we would not be handling, okay, yeah.
Right. So the last,
That's not like setting an input range on a.
An actuator.
right.
No.
So the last thing I'll call attention to is we have a static pressure bypass controller for these rooftops as well. It's actually our analog VAV, our new small footprint analog VAV controller. But if you run it in reverse acting mode, now we're controlling static pressure. So you can apply this to the bypass damper. There's a potentiometer to set what that static pressure limit is. So 1/2 inch, 1 inch, whatever you'd like, up to 2. And then you just let it go. You can either set it with the pot and have it be standalone, or the FlexStat can give it its static pressure set point.
Was that just a feedback going to the FlexStat? Or
Yep.
Yeah, you'll notice the.
Yeah, in this-
GoPro ties in.
From the ZEC standpoint, if you can set the set point through the menu. You know, say you put it at 1 inch, it's going to put out 1 volt and control at an inch of water, and then feed back the live signal back to the FlexStat so you can trend it.
Okay. And then the actual sensor hooks straight to the.
Right. But if you didn't have this, then this still has the capability of being configured for whatever pressure you want to maintain on its own. So, and we've had that, we did a little bit of testing. We can control down to 0.1 inches of water on 100 feet of 3/8 tubing. So all the dependencies you've normally gotten out of the flow sensors pretty much gone away. Right.
Well, that's where those kits come in handy too, because, you know, that flow probe assembly you see up in the ductwork, the SSS probe, that's a kit you can buy from us. So it's truly, we put it together to be as clean as possible.
But there you're just using this duct stat, probably doesn't do the high.
Yep.
Yeah.
Well, you're using both too.
Well, here we're turning our flow probe the other way, so we're picking up static instead of velocity. And then we're just hooking to the high here, exhausting the low side to atmosphere.
Oh, those are your SS1s?
Yep.
Yep, okay, yep.
Yep. There are actually new SSS or SSS1s now that so we can do 3/8 tubing direct or 1/4 inch direct without any fittings.